Dear friends, so far in the previous sessions for module 2, what we have learned is we have learned how to evolve a mathematical model for various systems such as mechanical system, electrical system, thermal system, hydraulic system, pneumatic system, as well as the liquid level system. How did we arrive at the mathematical model was we made use of the basic laws of nature, such as if it was a mechanical system, we made use of the Newton's second law. If it was electrical system, we made use of the Kirchhoff's law and Ohm's law. And then we also adopted the network approach, because it is easy to analyze an electrical network rather than arriving into some complicated situations with some other approach. Then we applied law of conservation of energy to evolve a mathematical model, or rather transfer function, for the liquid level systems as such. Now, the syllabus for this subject, as per the Visvesvaraya Technological University, the syllabus that has been composed, it is with a proper objective as well. It is with a perspective that it is the engineers, be it mechanical, be it electrical, or be it electronics engineers, it is these engineers who are involved in the design and development of any good control system. Whereas the end user will not have anything to do or anything to learn about how the control systems are evolved and the insight of the construction or the design of any control system. Whereas engineers, since they are the people who are going to design, since they are the people who are going to develop the control system, then what all is important for these engineers to know about the subject, that has been composed inside the syllabus of this subject of control engineering. Now, if an engineer has to design and develop a control system, then if he is given with a problem of developing a control system for some mechanism, then he will be very keen, or he will be required to know the function that is performed by each of the component of the system. A system may comprise of several elements, and the person who is involved in design and development of the control system, he will be very much interested in knowing what is the function performed by each of the component of the system. That is number one. And then he will also be very much interested in knowing what is the interrelationship that exists between various components of the control system. Now, in order to know the function performed by each component of the system, we make use of a diagram that is known as block diagram. That is what we are going to learn here. What are the block diagrams and how to make use of the block diagrams, so that we will arrive at the overall transfer function for any given control system, right? Now, what is this block diagram? A block diagram is nothing but it is a pictorial representation which represents the function that is performed by each of the component of a given control system. And also the network, the connectivity of each of the component will be made with the help of a circuit diagram, because of which we will also be able to know what is the interrelationship that exists between various components of a control system. If we try to represent a block diagram, how do we write a block diagram? If we try to depict over here, then see, if suppose I will take the example of the fan itself. What is the input given? Fan, the entire assembly, the switch, the conducting material, the induction motor, the condenser, the blades of the fan, the hub as well as the bearing, all of it, if it is composed as a plant or a system, then I will represent that entire assembly with the help of this block. Then what is the input given to the fan assembly? It is electrical energy. So, electrical energy as the input to the fan assembly. Now, where are we giving it? We are giving it to the fan assembly. So, I will write it as fan assembly. Then, what is it that I am going to get? The given input of electrical energy is processed by the fan assembly, because of which the output that is coming out from the fan assembly is nothing but mechanical energy in terms of rotation of the fan. What do we get? We give the input to the fan assembly, that is the electrical energy. The fan assembly is going to process the electrical energy, and at the end what output we are going to get is nothing but the rotation of the fan. So electrical energy is the input, then the rotation of the fan, it is nothing but the mechanical energy. Now most of the systems, most of the simplest systems can be represented with such a diagram. Now in general, what can be the mathematical relationship that we can write to this particular block diagram, to this particular block diagram representation, so that we can model it. Now what I can say, I will generalize this particular network, and I would say that the input, any plant or mechanism, I will write it with the help of a block diagram. Then what is the input given to it? I may write, say, X of S is the input given to the plant. Then what happens inside the assembly, inside the mechanism, or inside the machine, or inside the plant? Whatever happens, I am going to represent it with the help of G of S. What it means to say is the function performed by, if it is a fan, whatever happens starting from the switch till the rotation of the blades, whatever happens inside the fan with the electrical energy, if that is to be represented as a function, and if that function is represented by G of S, that is what I have written here as G of S. So X of S is given to the assembly, say fan assembly, if we are considering the fan assembly as the example, X of S is the electrical energy, it is given to the fan assembly, which is functioning, and its function is represented by G of S. What is available to us is mechanical energy as the output. Let me say that output is represented by Y of S. Now this is what is the block. So what is this block? What is the diagram? It is a block which is representing the function of the various components of the fan assembly. This is the basic. Now one more very important thing before we get into the application of block diagrams as a part of the syllabus of the subject, it is important to know various other aspects which are related to the block diagrams. One of them is called summing junction, or rather it is also called summer. We all know that a simple closed loop control system can be represented as input RS is given, then it is fed to the plant or mechanism which processes the input and give us the controlled output. Then since it is a closed loop control system, this is measured by a measuring device. The output is measured by the measuring device, which is represented by H of S. The functionality of the measuring device is feedback device is nothing but HS. Then the outcome from this feedback device is nothing but feedback signal. This is represented by B of S, and then this is given back to one of the very important component, which normally I address it as the replacement or the substitute for the human brain. What does the human brain, what is the importance of human brain in human body? Controls the every single action that the human body or the various organs of our body does. So that is why it is addressed as controller. So the same kind of a job, the same job is performed by this circular representation inside your block diagram in the circuit. So this feedback is given to the circular representation what has been written here. This could be addressed in various different ways, right? If we say, if we address it in regards to the detection of error, what we can say is it can be called as error detector This can be called as error detector. Then it can also be called as controller. Also, since what is wanted and what is actually got, both will be fed to this particular representation, and the role that it does is it will sum up both what is wanted and what we have already got, and then it calculates the error or corrections, and the correction signals are fed to the working mechanism. That is why it is called, since it is going to sum up both the given input as well as the actual output that is given by the feedback signal, it is also called as summer. That is what is the topic that I am talking about now. This circular representation what is present here, this is called the summing junction or summer, as the name itself indicates. Here at this particular junction, what happens is the given input as well as the feedback which is carrying the actual output from the system, both of them get summed up, and resultant is the error signal. What is the error? And the error is fed to the error signal is fed to the actual actuating mechanism or the plant, there where the correction will be incorporated. In case we are not getting what is actually desired of the system, then this error signal will act as the informer to the plant so that the correction can take place and we get the controlled output at the end. Now, this summer or summing junction has few properties, very important properties that is to be known, because before we start using this, we need to know what are the important features of the summing junction or summer. See, as you can see over here, the summing junction can have any number of inputs. I will just put it again with an illustration. Say, this is the summing point or summing junction, or you can even call it summer. Then it can have one input coming into it, say positive input, say G1 of S, and the input to this G1 of S, let me say R1. Then there is one more input coming into it, this say it is negative input, say it is coming out of the block with the content G2 of S, which had an input of RS. Then there is one more input coming to it, say this is a positive input from the block G3 to which the input was R3. Now, whatever may be the number of inputs to the summing point or summing junction, the output will always be 1. The output always be a single output. It can have, so the very important property for any summing point or summing junction is that it can have any number of inputs, need not just be 1, 2, 3 or 4 or as such. It can have any number of inputs, but the output from the summing junction will always be a single output. So if we just try to see what is the output, then what we can say is CS is equal to this and this multiplied together, because as we can see, CS divided by RS will be given by G1 of S. This is what is the relationship that exists. So if you want to know what is CS, then R1S into G1 of S. That is how we can write the relationship. So because of which CS will be equal to sum of all of them. So it can be written as R1 G1 of S. Then since it is summing, this is a negative input. The second input that is getting into the summing point or summing junction is the negative input. So I have to write it with negative sign. It is written here with the negative sign. So R2 G2 of S. Then the third input getting into the summing point or summing junction is a positive input. So plus R3 into G3 of S. This is what is the property of a summing point. Now, with these two inputs, let us start moving forward into the block diagrams and its applications. We will just try to learn, because this what has been drawn over here, this is the simplest of the closed loop control systems. This is the simplest of the closed loop control systems. So let us try to learn, since we have to arrive, see what is the application of block diagram. Let me just tell you first. The application of block diagram is that a given control system which has got several elements, each element or component will be represented with the help of a block, and the complete mechanism or the system will have as many blocks as many as the number of components of the system, and whatever way in which each component is connected with one another, the same way the signals will be connecting each of the block in the 100% same fashion as the various components would have got connected to one another. Now what do we do here? Why we are carrying out this exercise? Why we are making use of block diagrams? What we tend to do is, with the help of block diagrams, and there is one concept that is known as block diagram reduction. So with that, what we will be able to do is, we will start reducing the number of block diagrams of the circuit, and then we will arrive at the end into a single block, and that single block will have one input and one output. The content of that single block is what is the transfer function, the overall transfer function, or the function performed by the entire assembly. Even though there may have been 100 components, but all the functions of all the 100 components will be integrated and consolidated with the help of block diagram reduction rules, and at the end we will be ending up with the transfer function, which is nothing but a single block. The content of the block is nothing but the transfer function with single input and single output. So for that, what we will be first learn is, these are all the inputs, whatever has been written here on the board, these are the inputs to that state to be reached. So let us first learn how to derive a transfer function of, a simple closed loop control system. This is the simplest closed loop system. What you can see over here is, it is with how many inputs are there? As you can see, there is a single input. Then how many outputs are there? There is a single output. Then what is the kind of feedback? Is it a positive feedback or negative feedback? As you can see here, this is what is the feedback element and signal, and this is negative. That means to say, it is a negative feedback system. So overall what we can say is, here with this following derivation, we are trying to derive the overall transfer function of a closed loop control system, which is having a single input, a single output, and a negative feedback system. This is the given closed loop control system. What all does it have? It has got an input RS. It is given to the summing point. From the summing point, the error signal is coming out. This error signal is given to the plant with the functionality G of S. So there, this signal is processed and you will get the output. Output is what? It is represented by C of S. Now, whatever is the output, it is the actual output, or what we can call rather is controlled output. Now, this controlled output is measured with the help of the feedback element. The functionality of feedback device is termed as HS. Now, what is coming out of the feedback device is called the feedback signal. It is represented by B of S. This is fed again to the summing point. Then what will happen? The working, let me tell you, as soon as the feedback reaches the summing point or summing junction, the summing junction is going to compare, or it is going to sum up the actual input given and the feedback. Then if it is a negative feedback, then more of input is to be given. That is what is the error signal. This will be given to the plant so that you get the controlled output. This is what is the given system. For such a system, that is a closed loop control system having single input, single output, as well as the negative feedback, we need to derive the overall transfer function. Now, as per this relationship, what we can say, consider only this part, ES being given to GS block, and then what is coming out is CS. What we can write is CS divided by ES, the transfer function of only this component, only this part. If we write, then transfer function could be written as CS by ES is equal to GS. That is what I have written here. the transfer function of this forward path. Then if we consider this path starting from here till here, then the transfer function of this feedback path can be written as Bs by Cs, because Cs is been fed here. So Bs divided by Cs will be equal to Hs. That is what has been written here. Then we know that what is error signal, as I have just now mentioned. We know that error signal Es is equal to the sum of the given input to the summer as well as the feedback signal, that is Bs. So Es is equal to, error signal Es is equal to Rs. Then if it is plus here, I will write plus. If it is minus here, I will write minus over here. Since in the given system, it is a negative feedback system, I will be writing minus here. I will accord this as equation 1. Now, from these equations, what is Bs? It is equal to Cs into Hs. That is what I have written. I will name it as equation 2. Then from this equation, from this relationship, Cs is equal to Gs into Es. That is what has been written here as equation 3. Now it is just about mathematically making the use of these equations to arrive at the overall transfer function. Why? Because as I have been repeatedly mentioning in the previous sessions also, before you could start solving the problem, you must first plan the solution and you must know what is the result that you are supposed to get. In the given system, what could be the overall transfer function of the given system? What is the output? Cs. What is the input? Rs. So ratio of Cs by Rs, that is what is going to be the overall transfer function of the given system. So start making use of these equations. See, Es is there, Rs minus Bs. Bs you have got here, substitute it over here. See, this is what I have done here. Once you substitute, what we have got here, Es, Gs into Hs. Right. Now, once you have made this substitution, you can bring Es terms on one side and rest of the terms on the other side. That is how I have got Es into 1 plus Gs Hs is equal to Rs. Then if I send this on the right hand side, it goes to the denominator, we will get Es is equal to Rs by 1 plus Gs Hs. Now you have got the value of Es, right. So substitute the value of Es in equation 3. This is the equation 3. Substitute the value what you have found out over here in equation 3. Then in place of Es, you will be writing this right hand side, Rs by 1 plus Gs Hs. That is what I have written over here. Then it becomes Cs is equal to Rs divided by 1 plus Gs Hs multiplied by Gs. Then what is the overall transfer function you need to find out? Cs by Rs. Therefore, you cross multiply, you send this Rs onto the left hand side, it goes to the denominator, and whatever is left on the right hand side, that will be the transfer function. What is it that you are left here? It is Gs by 1 plus Gs Hs. That is what is the overall transfer function for a single input, single output, negative feedback, closed loop control system. Now, there may be many cases, like this can be considered as case 1, this can be considered as case 1 because you can even have positive feedback. It is not necessary that you must always work with a system which is having negative feedback. You can even be given with a system which is giving you the positive feedback. So if there is a positive feedback system, what will happen? As you can see over here, Rs remains the input, so obviously it will always be positive, whereas the feedback what was coming here, it was negative in the previous case. Now if it is positive feedback, then what will happen? The simple change that is going to happen is Es will be equal to Rs plus Bs. That is what is the simple change. Rest everything else will remain the same. Then this plus sign will make everything to change in the derivation. Why? Because here it remains the same. What? Bs, using the same terminology, what we can get is, see, Bs is equal to Cs into Hs. Bs is equal to Cs into Hs as we had written. Cs is equal to Es into Gs. Cs is equal to Es into Gs, right? Then Es will be equal to, because of these two relationships, if we substitute for Cs, if we substitute for Bs in this equation, then what we get is ES is equal to RS plus CS into HS. Then what we can do, in place of CS, you can substitute ES and GS. That is what has been done over here. Then again what we will get here is ES, if we take it on one side, ES into 1 minus GS into HS is equal to RS. It is 100% the same derivation as it comes over here. There will only be a significant change in the sign that we use because of negative feedback or positive feedback. Once you have got ES into 1 minus GS HS is equal to RS, then what you can do is ES, if you retain it on the left hand side, you will get RS by 1 minus GS HS. If you can observe over here, we had got, because of positive feedback, negative feedback, we had got RS by 1 plus GS HS. Here we have got RS by 1 minus GS HS. Then same thing, substitute for the value of ES in equation 3. That is what is being done here, because of which what will happen is, in place of ES, you will be writing this value. That is what has been done over here. And since we need to find the overall transfer function of this system, and that is going to be CS by RS again. So CS is here, RS you cross multiply, it goes to the denominator. What you are left here is GS divided by 1 minus GSHS. What we had got in negative feedback system, we had got CS by RS is equal to GS by 1 plus GSHS. Here for positive feedback system, we will get GS by 1 minus GSHS. That is the case 2. Then case 3, it can be a simple closed loop control system with negative feedback, but it is not just negative feedback, it will be negative unity feedback system. That means to say the feedback signal will be equal to 1. So in such a case, what will happen? See here, we know that for a negative feedback closed loop control system, what was the transfer function we arrived? GS divided by 1 plus GSHS. That is what I have written here. The transfer function is CS by RS is equal to GS divided by 1 plus GSHS. Now the case is negative unity feedback system. So what it means to say is, unity feedback system means this HS is equal to 1. So that is what has been written here. Therefore HS is equal to 1, because of which this transfer function is going to be GS divided by 1 plus GSHS. See, the circuit remains the same. Only thing is, see, HS, what is present over here, it is equal to 1. Okay. Then fourth case could be like, it is a single input, single output system. It is having a feedback also, and the feedback is positive feedback, but again positive unity feedback system. This is one more case to be discussed. Now we know that for positive feedback closed loop control system, we have just now derived the transfer function is nothing but CS by RS is equal to GS by 1 minus GSHS. That is what has been written here. And we have learned from the just previous case that if it is unity feedback system, HS will be equal to 1. HS will be equal to 1, because of which the overall transfer function could be written as CS divided by RS is equal to GS divided by 1 minus GS into HS is 1. So it remains GS divided by 1 minus GS. So even here, if you can just see, it could be 1. This could be this could be 1. Okay. So all the 4 cases that are going to be there. So any time during the block diagram reduction rules application, any time you will come across such a circuit as a part of the given control system, then in place of this, if it is single input, single output, negative feedback system, this entire thing could be replaced as, it is CS, this is RS, and this entire circuit could be replaced as GS divided by 1 plus GS HS. Similarly in all the other cases. Now after knowing what is the block diagram, then what is a summing junction, as well what could be the replacement for a simple closed loop control system as per the previous derivation, that is Cs by Rs is equal to, if it is a negative feedback, single input, single output closed loop control system, then what we can replace with a single block, what we can replace a closed loop control system circuit, that is also have been learned. It is nothing but Gs by 1 plus GSHs. Now, as I was mentioning, the very objective of learning the block diagrams is nothing but we want to make use of the block diagram reduction rules so that we can consolidate all the components and their functions into a single assembly that could be represented with a single block, and the content of the block will be the functioning of the entire assembly of the plant, which will be involved in transforming the given input to the output that will be availed at the end. Now, what are those block diagram reduction rules? Here are the important block diagram reduction rules. As you can see, the rule number 1 says cascading or series. So, what it means to say is, whenever in the given block diagram circuit, if it is a problem, if a system is represented in such a way that two blocks, two components are adjacent to one another, if the two blocks are adjacent or in series with one another, and if their contents are represented by say G1 and G2, then if we want to replace these two blocks with a single block, what should we do? Then equivalent circuit can be written as a single block having the content G1 into G2. What it means to say is, whenever two blocks are in series, their content can be multiplied and these two blocks can be replaced by a single block. Then rule number 2, if the given block diagram circuit or the problem or the system represented with the help of a block diagram is such that there is a block and parallelly there is one more signal with the block going into some summing point, then what we can say is we can accord this as the forward loop. This has the forward loop, and if this entire thing has to be eliminated or replaced by a single block, then the rule number 2, that is elimination of the forward path or parallel path, will come into picture. What will be the equivalent replacement for this particular circuit is a block containing, if these two are going into the summing point and both of them are positive, then it will be G1 plus G2, and if one is negative, say this could be plus or minus. If one is negative, then if it is negative going into the summing junction, then it could be G1 minus G2. That is why it has been written as G1 minus G2. So that is why if the forward loop we want to eliminate, if it is positive, then it will be G1 plus G2, and if it is negative, then it could be G1 minus G2. So that is why, depending upon whether it is positive or negative, the loop that we want to eliminate, it will be positive or negative sign over here. So what it means to say is, the content of the block could be summed up inside a single block, that will be the replacement for this forward loop. So this entire loop, this entire circuit can be replaced by a single block having a single input and single output. Then if you come to the rule number 3, eliminating a feedback loop, this is what we have derived previously. The derivation that we carried out to obtain the overall transfer function for a single input, single output negative feedback system, this is what we have. This is what is the circuit for which we have derived the overall transfer function. So what could be the replacement? If the feedback is negative and if it is single input, single output, then a single block with G1 by 1 plus G1 G2, sorry, 1 plus G1 H1, this will be the replacement. Now, if the feedback is positive, we have seen in the case 2, if the feedback is positive, then the replacing block will have G1 divided by 1 minus, if it is positive feedback, then it will be minus G1 H1. This is what is the equivalent circuit you can replace for the simple closed loop control system. Now, rule number 4. if there is a summing point ahead of the block or before the block, say G in the given circuit, then if for reducing or solving the block diagram network, if we are required to move the summing point after this block, then what has to be done? Then as per the rule says, if we want to move a summing point beyond or after this block, then see here, this is the equivalent network. What? You have moved the summing point from here till here, and what is to be done in such a case is, you need to add the block beyond which you are moving the summing point into the path. So, see, this is the block beyond which we have moved the summing point. So, therefore, this block got added into the network. This will be the equivalent network. Then, if suppose you want to move the summing point ahead of the block, if this is the summing point and there is a block G, and for me, in order to solve the block diagram circuit, if the summing point has to be brought before the block G, then what has to be done? See, this is what is the replacement. What? I have moved the summing point from here till here, and what I am supposed to do in such a case is, I am to add the reciprocal of the block ahead of which or before which I have moved the summing point. So, this is why if G is the block before which I have moved the summing point, so reciprocal of the block has been added into the path. Now, rule number 6, what does it say? Moving a takeoff point after a block. If suppose there is a block G and this is the takeoff point, this is called a takeoff point. And if to solve the block diagram network and arrive at the transfer function, if I am supposed to move this takeoff point after the block G, then what should I do? See, this is what is the equivalent circuit. See, I have moved this takeoff point from here till here, and what I have to do in such a case is, I have to add the reciprocal of the block after which I have moved the takeoff point. That is what has been done here. Then, if rule number 7 says, if I have to move the takeoff point before a block or ahead of the block, before a block or ahead of the block, then what is the replacement? See, if this is the case, there is a takeoff point, there is a block G, then if to solve the problem given, if I am supposed to move this takeoff point before the block G or ahead of the block G, this is what has been done here. In such a case, what should be done? In such a case, when I am moving the takeoff point from here till here, then a block containing the same content ahead of which I have moved the takeoff point should be added over here. These two rules are just opposite to the rule number 4 and 5. What you will be doing if you have to move the summing point after the block, the same will be the same action you will be taking if you are supposed to move the takeoff point before the block. What you will be doing to move the summing point from after the block to before the block, the same you will be doing to move this takeoff point from before the block to after the block. Now, if suppose, rule number 8, if suppose you are supposed to move a takeoff point after a summing point. If this is the existing case, original case, here you can see there is a summing point, there is a takeoff point. If for solving the problem, if you are required to move this takeoff point after the summing point, in such a case what you have to do? So, this is what is the representation. This can be the equivalent for, or this can be the replacement for this circuit. What? If you are moving the takeoff point from here till here, then you have to add a summing point. Then, rule number 9, what it says? Adding a summing point. See, here this is the case, the original case, what could be taken as example is this. Here you can see there are 3 inputs to the summing point and there is a single output. Now, for any requirement to solve any block diagram circuit or control system problem to arrive at the transfer function, if you are required to break this summing point into 2 or more, then how can you do it? That is what is written here as adding a summing point. So, in such a case what you can do is, see this input we have written here, we have written the summing point, then this input has been written. Then again continuation, it makes no difference, and then there will be a summing point and this input could be given, and what comes out, it will be the output from the system. So, these are the 9 rules what are there for our help and support, so that any problem or any given control system to be solved, and we have to arrive at the transfer function using block diagram reduction technique, then these rules can be used to arrive at the transfer function. Now, considering that, let us try to solve one simple problem over here using the block diagram reduction rules. Problem number one. The given problem, say for example, okay, say this is the given problem. What? There is an input R, there is an output CS, then G1 and G2 are there in the forward path. These are the two components represented over here. One component function is represented by G1, the next component function is represented by G2. There is a feedback element having the feedback signal as feedback element with the functionality H1. Now, how do we solve this? As per the rule number 1, if two blocks are in series, if two blocks are adjacent to one another, without anything in between them, there is nothing in between them, in between these two blocks there is nothing. If there is something, if there is a takeoff point or anything is there, then you cannot cascade readily. So, just like that, here as you can see, these two blocks G1 and G2, they are in series, there is nothing in between, because of which we can apply the cascade rules. Apply cascade rule, because of which what you can say is rewrite the circuit according to the cascade rule. G1 and G2, these two could be replaced by a block containing the product of G1 and G2, and rest remains the same. Now, once you have got up to this, is it not resembling rule number 3 original circuit? This is a simple closed loop control system having single input, single output and negative feedback system. So, for which what is the replacement? The replacement is G1 by 1 plus G1 H1 as has been written over here, because of which we can say this is to be replaced by, for this replacement is, if you consider this as GS and this as HS, then what you can say is GS by 1 plus GS HS 1 plus, since it is a negative feedback system, it should be GS divided by 1 plus GS HS. If it was supposed to be positive feedback system, what we should have written is GS by 1 minus GS HS we should have written. Now, since it is a negative feedback system, what we can say is GS by 1 plus GS HS. What is GS HS here? It is G1 by G2 divided by what is 1 plus GS HS. GS is G1 G2 and HS is 1. So, the output remains CS, input remains RS. Therefore, the transfer function is CS divided by RS is equal to G1 G2 divided by 1 plus G1 G2 H1. This is the simplest illustration of the block diagram reduction rules. Here you can see this problem demonstrates that a system is represented by two components inside it. There is a controller and there is a feedback device. RS is the input given to this system, which is processed by both of the components represented by the function G1 and G2. Ultimately, we are going to get CS as the controlled output. Now, this output is measured by a feedback device with functions that is represented by H1. This is fed to the controller or summing point or summing junction, and we have found that it is a negative feedback. That means the output is not as per, it is lesser than the desired output, or whatever input has been fed to the system, the output is not proportionate to the input, in fact it is lesser. That is what it says. Now to this is the way in which we have applied the block diagram reduction rules, and finally we have arrived at the transfer function. What does it depict, or what does it indicate is this entire assembly of the system has been brought down to a single block. That means the entire assembly functionality has been derived with the help of block diagram reduction rules, and we have got the overall transfer function as G1 G2 by 1 plus G1 G2 H1. Let us solve one more problem, that is problem number 2. As has been written over here, there is an input, there is a component whose functionality is represented by G1. Then again there is a summing point, there is another component with the functionality whose function is represented by G2. Then we get the final output. Then there are two feedback signals. One is H2, which is going into this summing point, and there is one more feedback signal where there is no H1 or H2 written. And a universal principle is that whenever there is nothing written in the path of the signal, then that means to say we have to assume it to be unity. If in the feedback signal, if the function is not written over here, then we must assume it to be unity. That is why nothing would have been written. The same remains the case even if in the forward loop also, but still very normally we will find unity in the feedback system only. So we will assume that as the unity, and that is a universal principle. Now in order to derive the overall transfer function for this given system, how to solve? Let us try. So what you can say is, see, this line is connected to this feedback signal. How we can assume is, it can be rewritten as rewritten in this particular fashion, right? Because since this is only the second problem, I must make more or less everything clear with you people, that this common line is nothing but this is common to both this feedback as well as this feedback signal. So I have just separated that and written it. Okay. Then next point is, see, if you observe over here, this part of the network, is it not resembling a simple closed loop control system or simple feedback system? Yes, it is resembling. So what rule can be used there? We can use eliminating the feedback loop. Yes, we can eliminate the feedback loop. So the very next step will be, I am eliminating this. So GS is nothing but G2, HS is nothing but H2. So what could be the replacement? GS is nothing but G2, so G2 divided by 1 plus GS HS, 1 plus GS is G2 and HS is H2. So this is replaced by a single block, and this remains in the unity feedback system. Now, what you can see over here, these two blocks are in series. These two blocks are in series, because of which rule number 1, that is cascading, comes into application. So therefore, these two should be multiplied. So G1 G2 divided by 1 plus G2 H2. This will be the next step. Now, once you come to this juncture, now what you can see, this entire network represents a simple feedback system, as you can see over here. Only thing is, Here H1 is present, there since nothing is there, H1 is nothing but 1, so it is a unity feedback system. Therefore, what you can say in place of the entire thing, finally what you can write over here is this becomes GS and 1 becomes, unity becomes HS. So, G1, G2 divided by 1 plus G2, H2 whole divided by 1 plus GS HS means GS is the entire thing, HS is 1, therefore G1 G2 divided by 1 plus G2 H2, this is GS and HS is 1. HS is 1. So, because of which we got to know that this entire thing from 2 summation points, 3 components and 2 feedback points, we have brought it down to a single block whose content is the transfer function. And very normally the practice has to be, it must be simplified. If we just try to simplify it, what can we get? I'll just try to simplify it over here. This part I'll try to simplify, that is 1 plus G1 G2 divided by 1 plus G2 H2. If I try to simplify, I will get 1 plus G2 H2 into, sorry, one plus G2 H2 plus G1 G2 divided by 1 plus G2 H2. This is what I am going to get. If I just replace that over here, then finally what I can get is this denominator and this denominator both will be the same, because of which the final transfer function that I may get will be equal to G1 G2 divided by 1 plus, this one remains G2 H2 plus G1 G2. This will be the overall transfer function for the given problem. Thank you.